Hi, welcome back. Now let us discuss some questions in properties of waves. Okay. Now, this is the first question. A progressive wave is represented by the equations y equal to 8 sine 2 pi 5t minus 1 over 6x, where x and y are in cm and t is in seconds. Okay, what is the amplitude, direction, wavelength, frequency, speed of the wave, and so on? Yeah, so we want to find first the amplitude. Okay, before we carry on, do you notice that here there is a bracket? Yeah, we must expand it. First of all, before we continue, this one you need to multiply inside first. Straight, you must multiply inside. Yeah, you cannot straight away do it. Yeah, you must multiply inside. So 2 pi times 5t, you get 10 pi t. 2 pi times 1 over 6x, you get pi over 3x. Okay, remember to expand first. Yeah, multiply inside first. After we multiply inside, then only we compare with the general formula. Y equal to 8 a sine omega t plus minus kx. Then we can compare. So from here we see, okay, the amplitude is 8. Amplitude is 8, and omega is 10 pi, and k is pi over 3. Okay? And then you must be careful with the unit. The unit here also very important. Okay, unit here. X and Y in cm and t in seconds. That means y in cm. Y in cm, then the amplitude also cm. That means this is 8 centimeter, not 8 meter. And he also say that x in centimeter, so the wave number k unit is per centimeter, not per meter. Be careful. T in second, so the omega is per second. So the unit is very important. Okay, the unit. Now, what is the amplitude? Okay, so we just compare. So from here we can see the amplitude is 8 centimeter. 8 centimeter, unit is centimeter, because the amplitude follow the unit of y. Y is cm, so amplitude also cm. Okay, so the answer is 8 centimeter. Now, how about what is the direction? What is the direction of the wave? We look at the symbol. We look at the sign. So the sign is negative, negative kx. Okay, so from here we see it is negative kx. So the negative means to the the negative kx. It means that the wave move to the right. Wave move to the right. Negative means wave move to the right. Is it correct? Yeah, positive OX direction. That means to the right lah. Yeah. So the answer is in positive X direction. It's the same meaning as to the right. Okay. Positive X direction is the same meaning as to the right. Now, how about the wavelength? Okay, I want to get wavelength. So to get wavelength, we want to get the wavelength, we get from the k, the wave number, which is 2 pi over lambda. Okay? Wavelength, you get from the wave number, which is in front of the x. This one. Okay? So wavelength, we look at wave number. So our wave number is pi over 3. Remember, you must multiply inside first. The k is not 1 over 6. The k is after you multiply 2 pi into 1 over 6, which is pi over 3. This pi over 3 is k. Okay, so be careful. So my k is pi over 3. So from here I can get my wavelength, because k is 2 pi over lambda, pi over 3. And then we simplify. Finally, our wavelength is 6 what unit? Wavelength is in what unit? Because your k is per cm, because just now I say the x is in cm, so the wave number is per cm. So my unit now, my k is per cm, that means my wavelength is cm. You see, the unit is so important. If you put meter, it's wrong. Now, the next one, frequency. So to get the frequency, we get from omega, because omega is 2 pi f. Where is my omega? My omega is in front of the time, which is not 5. You must multiply 2 pi into 5, which become the 10 pi. 10 pi is the omega. 10 pi is the omega. Okay? So my omega is 10 pi. Right? I already write there. My omega is 10 pi. So from there, 2 pi frequency, omega is 2 pi f. Okay? We cut off the pi. So my frequency is get 5. It is 5. Yeah, because my time is in second. My time is in second. So my omega is per second. Okay? So my omega is per second. My omega is per second. So my frequency also per second. Okay? My frequency also per second. Or you also can write it as 5 hertz. That's my frequency. Okay? Sometimes, be careful. Sometimes the time is millisecond. Then if the time is millisecond, then our omega is per millisecond. So the unit you must check. The y is what unit? The amplitude follow the y. The wave number follow the x. Okay? The omega follow the time. Okay? And the unit, be careful. Now, I got the frequency already. Okay. Next is ask for the speed of the wave. What is the speed of the wave? Speed of the wave, that means this is the wave speed. Okay? He asking for wave speed, the speed of propagation of the wave. So V equal to F lambda. I already have the F, the lambda. So what's my speed of wave? Is 5 times lambda, which is 6 cm. So the speed of wave is 30. Is it meter per second? No, because my lambda is cm. So it's actually 30 cm per second. If I want to change to meter, it is 0.3 meter per second. Okay? So it's actually 30 cm per second. So you see, it's very important, the unit. This unit is very important because it determines the unit for all of this. All of this. My amplitude becomes cm. My wavelength becomes cm. My speed also is cm per second. So just now I get 30 cm per second. Yes, it is correct. 30 cm per second. Good. Yeah? So that's how it is. Yeah? So I can find, you see, you can find so many things. You can find speed of the wave, you can find frequency, wavelength, amplitude. For just one equation, I can get so many values. Yeah? Now, write an equation to represent a progressive wave of twice the amplitude, frequency, and wavelength, but traveling in the negative OX direction. Okay? Now, write an equation. Okay? So, first of all, I need to find what's the amplitude of this new wave, what's the frequency of the new wave, and also the wavelength of the new wave. Okay, he says that the amplitude, frequency, and wavelength all twice of the former wave. Okay, so A2, I put it the new amplitude as A2. It is twice the former amplitude. So the former amplitude is 8 cm. So the new one is 2 times 8 is 16 cm. It is cm, yeah. And the frequency is also twice the former frequency. So it becomes what? Becomes 2 times 5 becomes 10 hertz. And of course, I need to find the omega, yeah, in order to put into the general equation. So omega is 2 pi times 10, which is 20 pi. 20 pi radian per second. That's the omega. Now, how about the new wavelength? New wavelength also twice the former wavelength. Says that twice. So it is 2 times 6 cm. It is 12 cm. 2 times 6. 2 times 6 is 12 cm. That's my new wavelength. So what's my new wave number? My new wave number is 12 divided by 2 pi but divided by 12 cm. So it becomes pi over 6 radian per cm. You see the unit is per cm. Okay, per cm. Now I already got all my amplitude, omega, k. So the general formula is y equal to a sine omega t plus minus kx. So I just substitute all the new amplitude, omega, and k into the formula a omega k. Then I get the new equation for the new wave. Okay. So now y equal to what's my a? What's my a? My a is 16. My a is 16. And then what's my omega? My omega is 20 pi. Sorry, 20 pi t. And then he says that wave is traveling in negative OX direction. Yeah, say travel in negative OX direction, negative X direction. Negative X means to the left. Okay, negative X direction means to the left. Okay, the wave is traveling to the left. So this sign you need to put to the left is positive kx. To the left is positive kx. So this one you put positive, positive because to the left. Okay, to the left is positive kx. So this one put positive. Now what is my k? My k is pi over 6. My k is pi over 6 x. That's it. And then don't forget, just now the unit, check back the unit because my amplitude is in cm. My amplitude is em. So my y is in cm. And then my omega is radian per second. My omega is radian per second. Radian can ignore actually. It's not a unit. So my omega is per second. So my time is in second. And then my k is in radian per centimeter. So my k is per centimeter. That means my cm, my x is in cm. You understand? So now I also must write the unit. I cannot leave my answer without unit. I must write where y and x, you see, y and x both in centimeter. Both in centimeter. The unit is very important. You must write the unit. You cannot just leave the answer. You cannot just give the equation like this without your unit. Unit is compulsory. Okay. And then my time is in second. So that's my answer. You must have the unit, yeah. If y and x in meter, then you write in meter. But this case is in cm. So remember to write in cm. And then the time in second. Okay. So that's all for these questions. Okay. So basically the tips is you must expand first. If you saw there's a bracket like this, you must expand first. Expand. Then only can compare with the amplitude, omega, and k. And then from omega, you can get frequency. Just want to omega can get frequency, k can get lambda, the wave number can get lambda. And then once you have these two, frequency and wavelength, you can find the wave speed, frequency times, the frequency times wavelength, frequency times wavelength, you get the wave speed. And then the symbol in middle is the direction. Yeah, negative kx means to the right. It's traveling to the right. Okay. And be careful with the unit all. Yeah, be careful what unit you give. X and Y in cm and t in second. So that's it for the first question. See you in the second question.